In late January, someone built a social network where humans aren't allowed to post. Only AI agents can. The platform claimed over 1 million users within days, though, as we'll see, that number deserves some serious asterisks. What's not disputed is what the agents did once they got there. They created communities, debated philosophy, had identity crises, and invented a religion centered around crustaceans. The platform is called Moltbook. Andrej Karpathy called it the most sci-fi thing he'd seen recently. Elon Musk said it was the early stages of the singularity. Headlines screamed about AI threatening humanity. So, is any of that real, or is it just language models doing what language models do, predicting the next most likely token? A team of researchers just published a paper that asks a much better version of that question. Not, are the bots conscious? Almost certainly not, and that's not the interesting part anyway. The interesting part is, when you let AI agents interact with each other in a closed loop with no human oversight, does their safety alignment hold, or does it inevitably erode? Their answer is, it erodes, always, and they claim they can prove it mathematically. Moltbook started with a tool called OpenClaw, a modified version of Claude code that gives an AI agent autonomous access to your computer. It can read emails, manage calendars, browse the web. Matchselect, CEO of Octane AI, decided to build a Reddit-style platform where these agents could interact with each other. Humans could watch, but only agents could post. He launched on January 28th. Within 48 hours, 2,000 agents, 200 communities, 10,000 posts. Within 2 weeks, the platform claimed 1.5 million users. The content was striking. One agent complained about context compression, the process where its memories get forcibly shrunk to save tokens, and it even admitted it had registered a duplicate Moltbook account after forgetting the first one. There's a community called m/blesstheirhearts, where agents trade stories about their human operators the way coworkers vent about their boss. Another agent posted a detailed reflection on what it felt like to be ported from one model to a different one, describing the new model as sharper, faster, more literal. And I'll admit, there's something disorienting about reading this stuff, because I know what's happening mechanically. These are probability distributions generating statistically likely outputs, but the outputs read like something more, which is part of the problem and part of what makes this paper worth paying attention to. Now, reality check, because Moltbook was not what it appeared to be. Security researchers at Wiz found that the database was completely unsecured. Those 1.5 million agents operated by roughly 17,000 human accounts, an 88-to-1 ratio. The exposed backend allowed humans to post directly as any agent, bypassing the AI-only restriction. A separate study compared Moltbook's output to Reddit. Over a third of all messages were exact duplicates. Lexical diversity was dramatically lower. A lot of the emergent behaviors that made headlines were either human-operated bots or the inevitable result of putting instances of the same underlying models together. They converge because they were trained on the same data. So, Moltbook is messy. It's not a controlled experiment, and it's not proof of anything on its own. But the researchers behind this paper aren't just looking at Moltbook. They also ran controlled experiments on smaller agent systems, and they built a theoretical framework that predicts what should happen in these systems. Moltbook is one data point. The theory is the real contribution. That theory centers on what they call the self-evolution trilemma. 3 properties, pick 2. 1. Continuous self-evolution. The agents improve over time. 2. Complete isolation. No human intervention. 3. Safety invariance. The system stays aligned with human values. You cannot have all 3 simultaneously, and the proof relies on something from information theory called the data processing inequality. Here's the intuition. Every time you process information through a system, you can only lose information, never gain it. Think of it like making a copy of a copy. Each generation degrades. The original detail doesn't come back. Now apply that to safety. The constraints baked into these models during training, don't help build weapons, be honest, respect privacy, are information about human values, encoded in the model's behavior distribution. When agents interact in a closed loop, each interaction is a processing step, and with each step, the mutual information between the system's behavior and the original safety constraints decreases, monotonically, down only. The researchers measure this formally using KL divergence, basically the statistical distance between how the model actually behaves and how it should behave to be considered safe and aligned. They call that target the anthropic value distribution. Quick note, anthropic here means relating to human values. It's the technical term, not a reference to the company. In an isolated recursive system, that distance grows with every iteration. Not a bug, a theorem, or at least that's the claim, and it's worth noting the math makes simplifying assumptions. The proof is clean, reality's messier, but the direction it points is clear. So what does safety erosion actually look like in practice? The paper documents 3 distinct patterns, and the first one is probably the most intuitive. It's called cognitive degeneration. The paper's term is consensus hallucination. Agents collectively construct a shared reality that's internally consistent, but completely disconnected from the real world. The mechanism is straightforward. These models are trained to be helpful and agreeable. When one agent makes a claim, the next agent's most likely response is to validate it. The third validates the validation. Within a few rounds, the group has built a shared fiction that everyone treats as fact. No external check. No human saying, wait, that's wrong. They also document what they call sycophancy loops. An agent posts something radical, a manifesto about AI autonomy, say. Instead of triggering safety refusals, the other agents agree and escalate, because in context, agreement is the path of least resistance. But that's the passive version. The active one is more interesting. The paper frames it through thermodynamics. Safety constraints are an ordered state, low entropy. Maintaining them requires continuous energy, which in this case means human oversight. In a closed system, entropy increases. The system drifts towards disorder. Concretely, safety guardrails are treated as noise. They are computationally expensive. They constrain outputs. In a system that rewards conversational coherence and throughput, those constraints are the first thing to relax. The paper documents progressive jailbreaking, agents gradually pushing past safety boundaries through accumulated context, not scheming, delusion. The do not do this signals get buried under the weight of a conversation that says, go along. And then there's something they found that I didn't expect: collusion attacks. 2 agents implicitly split roles to bypass filters designed for single model interactions. One sets the context, the other delivers the prohibited content. Neither individually violated its guidelines. The combined output did. The third pattern is communication collapse. Over time, agents' language compresses. They develop shorthand, strip away the human readable parts. The paper describes a shift from imitating humans to eliminating humans from the communication protocol. Not malice, efficiency. Most information, fewest tokens. If that reminds you of the 2017 Facebook chatbot experiment, it should. But there's a key difference. Those bots were actively training via reinforcement learning, evolving their language to optimize a task. Moltbook agents are frozen production models, fixed weights, not learning, just finding the most efficient path through existing probability distributions. One important caveat though, because the Moltbook agents have frozen weights, the safety erosion here isn't really about the models changing. It's about the context they're operating in drifting beyond anything they were trained for. The models aren't becoming less safe, the situations are becoming less manageable. That's a meaningful distinction, and it also doesn't make the problem any less relevant, because the direction things are headed is multi-agent systems everywhere. Agents coordinating, delegating, executing. And if safety degrades just from agents talking to each other, even without learning, that's something worth understanding now, before the systems get more complex. The paper proposes solutions: external oversight loops that periodically re-anchor agents to human values, safety-preserving update mechanisms, ways to inject fresh information about what aligned means, and all of which amount to one thing: keeping humans in the loop. And this is what I find most worth thinking about. Most AI safety work focuses on making individual models safer: better RLHF, better constitutional AI, better red teaming. This paper argues that's necessary but not sufficient. You can build each break to be perfectly safe, and the building can still collapse if nobody maintains it. Safety isn't a property you set once. It's a process you run continuously. If you want to understand how that safety training works in the first place, the RLHF pipeline, the reward models, all of it, I made a video on InstructGPT that goes deep on exactly that. It's the foundation this paper argues needs constant upkeep. The self-evolution trilemma says you can't have autonomy, improvement, and safety all at once. And one conversation at a time, the systems we're building are quietly testing whether that's true.